So, here are the top 10 things that I learned in 2014. And these come from working with the states, working with teachers to develop different things, to think about implementation. Number 10, eliminating the black box is tough. Now let me tell you what I mean by the black box. The black box is anything that when you're teaching your kids, you say, you're not going to understand this yet, but next year. Okay? It even happens just in the course of a classroom, right? I mean, if you're talking about something, and kind of here's my definition of a black box. If you have to just purely memorize something to do something else, you've created a black box. So if I really want to understand bonding, now, again, I'm a chemist, and I know there are probably people in the audience right now that have read the NGSS and go, oh, there's no chemistry in there because it doesn't say ionic covalent bonding. Well, here's why. How do we handle bonding? Ionic bonding is the transfer of electrons from typically a metal to a nonmetal. I am college and career ready, man. I am ready to go. You know? No, you're not. Because here's what the deal. What's the deal with learning about ionic and covalent bonding? Well, the issue is this. There are two objects acting at a distance. They have a force on one another. That's actually in PS2. That's the force in motion. Everybody looks for the chemistry in PS1. But you've got to look there. Now, because we know about scale, proportion, and quantity, which is a cross-cutting concept, I can actually take that and say, okay, my scale is, instead of talking about the planets in the solar system and how they act on gravity, I'm going to talk about two nuclei. And I'm going to say how this nuclei here has a greater electronegativity than this one over here. When you go, well, what the heck is electronegativity? Did you create a black box? Heck yeah, I did. So let's talk about what electronegativity is. Well, it's the tendency of an atom to pull an electron toward itself. What the heck does that mean? Well, what it means is there's a force. That force over here is pulling that electron over here. Well, what if I'm talking about covalent bonds? Well, that force at a distance thing, that's nice, but there's a bigger deal here. Oh, yeah, there is. If you look over in PS3 around energy, you're going to see something that talks about fields, energy and fields between things. Well, why does a covalent bond work? Because there's an overlap of orbits. And those electrons are trapped between there because of those energy fields. Holy cow. Is that a little bit deeper than what we've traditionally done with ionic and covalent bonding? Heck yeah, it is. But we have to think about that differently. And what we kind of get trapped in is this whole thing about, well, I teach high school chemistry, so I'm only going to look at PS1. If you're really going to eliminate the black box, which is really hard, because you have to really think about how your trajectory is going to run, you've got to really think about the whole picture. Teaching topics versus understanding phenomena. I mentioned gas laws a minute ago. Oh, goodness, I can't tell you how many times I get an email. How many days a week I get an email. The gas laws aren't here. You're a dastardly person. You're horrible. Well, let me tell you something, folks. Gas laws are important to understanding matter, not to understanding gas laws. Okay? What kids need to understand from a scientific literacy perspective is the structure and properties of matter. So if I'm just simply teaching kids PervNert, PV equals nRT, for those of you who haven't had your high school chemistry in a little while, I'm not talking about perverts. PervNert, PV equals nRT, it's got to be more than that. It actually has to be more. You've got to start thinking about, how am I going to use this to teach a phenomenon? How do you make sure that the girl is not upset with her boyfriend in February when he walks in from the cold carrying a balloon for Valentine's Day, and she thinks he's too cheap to have filled that balloon with helium? Right? That's actually understanding something more about gas laws than just simply Charles Boyles and PervNert. So just for those of you that are wondering, here you go. If I'm going to teach gas laws, There are parts of these that you have to know if you're really going to understand gas laws. Not if you're just going to do the math, because guess what? If you're just doing the math, are you teaching a novice or an expert? Say it out loud. Novice. Why? Because they're following a prescribed sequence. Otherwise, are they really taking it and having a systemic look at it? So, are they looking at being able to compare structure of substances at the bulk scale to infer strength of electrical forces at the middle? You know, we talk about ideal gases. How many are there? None. There aren't any. But it's a model, right? But we've got to understand that there's actually this thing, these interactions that are happening. What about Coulomb's law? Why does that matter? Well, because Coulomb's law helps us think about attraction and repulsion. What about looking at a combination of energy associated with the motions of particles and energy associated with relative positions of particles? That's definitely gas law. That's definitely Charles and Boyle. Because as you increase energy, you're going to increase distance. You're going to increase the speed of the molecule. Some of you are not chemists, so I'm going to go on because I don't want to bore you too badly. But number 8, simply reading the NGSS does not lead to NGSS expertise. Now, I've had people who have told me they've read it. Some have told me they thought about it. But here's what we found. In our work with teachers, we in partnership with NSTA, we developed a rubric called Educators Evaluating the Quality of Instructional Products. And specifically what that does is that it helps you evaluate a lesson or a unit to see what its alignment to NGSS is. And what we learned is actually it turned out to be a great professional development activity. In fact, in one state that piloted this for us, the person that was running the workshop said, okay, we want you to raise your hand. And we want you to raise the number of fingers that you think you are between novice and expert. So 1's a novice, 5's an expert. Raise your hand. You know, everybody in the room, 4s. Some people said 3s. But very few 1s and 2s. So they go through the whole equip thing. At the end of the day, one of the teachers said, can we raise our hands again? And there were lots of 1s and 2s. And somebody said, oh, so the scientific principle of NGSS is the more I learn, the more fingers I lose. Okay? So the point here is, the reason I'm telling you that story is because when you want to get into NGSS, you need to do it with a purpose for what you're doing. Don't just read them, because all it's going to be is a bunch of disjointed stuff. What doing an equip training, or what doing, what's going on with curation, with NSTA, what's going on with looking at evidence statements, tasks, when you are together with your faculty members, with your folks, and you're thinking about instruction, that actually is what makes you understand NGSS, not that I picked up a book and I read it. Number 7, if you can eat it, it's probably not a model. Now, in development for NGSS, we had a rule that if you could Google it, it wasn't a standard. Well, this is the new one. Now, some of you probably going to get mad at me in a minute. I am so very sorry. But models are very tough to understand. And, well, actually, they're not tough to understand. They're tough to understand if you think you're already completely doing it. Y'all have heard me say before, if you've heard me speak, you've heard this very statement come out of my mouth almost every time. I guarantee you that there are models in every school in the country right now, and that about 80% of them are edible. Jello molds of the cell, So what is a model? Yeah. What's a model? A model means that there are components of the model that you are defining the system you are studying. Well, a Jello mold of the cell, you could say, well, you're studying the cell, and there's mitochondria, and there's a nucleus, and there's, okay, all right. We'll go with that for a second. Then you've got to actually talk about the connection or the relationships between the components of the model. Well, you could still say, well, it's a Jello mold, and there's stuff in there, and the mitochondria supplies energy to these other things, and, okay. Here's the kicker. A scientific model, has a connection to a phenomena. which means you can explain phenomena. Now, I don't mean explain like the cognitive verb explain, where you just regurgitate what somebody else told you. Explain in science means you can support it with evidence. Okay? You can explain or predict future phenomena. Let me tell you what you can predict with the jello mold of the cell. Y'all watching? You got to watch this because I can't explain it to you. You ready? I can watch it wiggle, and I can watch it jiggle, but it ain't going to explain anything. The kid, perhaps, could add an explanation to that, but you can't really change that model to something new because of new evidence. So that's the thing about modeling. And the thing is, this is really about all of the practices. I mean, and I apologize for those of you that may have heard what I'm about to do, but I had about 25 people come to me, and you can tell you spoke a lot when you start getting requests. But this fits. I have to say it. This is really about all the practices. Practices aren't just cute things you do in the classroom. They have knowledge associated with them. So like what I just said about models, you've got to understand what models are and what they're doing. Same thing with argument, same thing with explanation, same thing with asking questions. We do this, think about what our country will become. A nation without warning labels. When you go to get on your plane to go home and they hand you a package of peanuts that you won't have to have a warning that says it might contain nuts. You will know the coffee is hot. You will know that when you buy stereo equipment and there's a little white packet in there that says do not eat, you're not going to go, look, I bought speakers and chiclets. You will know that with the sunscreen that goes up in front of your car in the window, it says do not drive. So glad somebody told me that. It may mean that when you get on a plane that we start to realize that there's some of the things flight attendants tell us that may not really matter that much. When I get on there and they start talking about your seat can be used as a flotation device, and I'm going where there's no water, I'm just going to die. That flotation device ain't going to help. On a tube of Preparation H, it says, do not take orally. And you know it's because somebody wrote a letter. Dear Preparation H, I ate a whole tube. My mouth is so small, I can't even eat a jelly bean. But I can whistle really good. So understanding these, it goes way beyond just doing it in the classroom. It actually goes far greater into what does a kid understand about it, because that's what's going to give you the depth. That's what takes you from skipping a flat rock across the surface of a lake and jumping into the lake and really starting to understand what science is about. Number 6, this one is a horrifying one for me. I actually have nightmares about this. Cross-cutting concepts are still the third dimension. I am worried that in 10 years I will write a book called The Lost Dimension. Cross-cutting concepts, I think, are probably the most misunderstood and also the most powerful dimension of this, because this is actually, we talk about, and I'm guilty of this, we talk about how these are the things that are similar in all of the sciences. But it's bigger than that. It's actually what kids use to apply things to bigger situations. Cause and effect. We want a kid to walk around and actually recognize there's an effect. Right? For that matter, we want adults to walk around and figure out there's an effect. So these cross-cutting concepts are huge. They're very, very important. But we kind of leave them out. They're kind of the thing. And here's the deal. Here's something we've learned as we've been working with our teachers is you can look at stuff and you can see where it's there. Because, with cross-cutting concepts, you can make the argument all 7 of them are there all the time, but they're not explicit. when we're using the equip rubric, you can't see them. But here's the real kicker. It's not just what you read that what the teacher's going to do. If the instructional materials don't elicit the student to actually talk about patterns or cause and effect or scale, proportion, and quantity, the kids aren't using it. So guess what? At best, you're two-dimensional. You're not going 3. Number 5, phenomena is underplayed and underappreciated. We still, so we're doing a set of model content frameworks right now. What model content frameworks are is these are the things that give you an example of how you can bundle the standards in a year, right? So what would your Unit 1 be, your Unit 2 be, your Unit 3 be? And when we first started working with our teachers that are doing this, it was very traditional. It was, well, I'm going to teach weather. Now, weather kind of is a phenomena, but, and at the high school, it was, I'm going to teach, gas laws, whatever. And it's really a big push to get people to really start thinking about what is phenomena that actually a kid could use. And often it's actually very difficult because you can actually base multiple units on the same phenomena. But here's the deal. So let me just step out of this for a second and talk about what everybody always worries about with the assessment. If we do a good job with NGSS and really do 3-dimensional learning, I mean really do it. I don't mean do each of the dimensions, but really do 3-dimensional learning. It doesn't matter the phenomena that will end up on some assessment somewhere, because the kid can apply that because they actually understand how that works together. In fact, we got a real problem. Standards-based education is big on standards but small on standardization. I don't know if you've ever heard that quote before, but it's where we kind of screw up, right? I mean, it's why we have our teachers using pacing guides that you have to be on this page on this day. It's why we have teachers writing the standards on the board. No, that's actually not what it's about. What it's actually about is how are we really getting to a better place of understanding phenomena. Oops, dang it, went too fast, now I don't know how to go back. Anybody over there know how to go back? Because this is a big one. Bundling is not easy. How many of you heard me talk about bundling before? You've heard somebody say bundling. All right, good. Here's bundling. In short, if you try to teach NGSS 1 PE at a time, A, you miss the boat. B, you're never going to finish. They were developed to be coherent. They were developed to be something that goes together. But here's a really important part, gang, and this is something that people just don't get. Why is bundling not easy? Because everybody, unfortunately, not everybody, that's not fair. A lot of people, because of how we've conditioned our culture and education, are waiting for the way to bundle. My friends, let me just tell you, if it doesn't make sense to you as a teacher, it will never make sense to the child. Ever. Ever. If you had tried to get me to teach a certain way in a certain order, I could have done it. My kids wouldn't have got a lot out of it, though. So you actually do have to really think about how this bundle, what does it mean for you? It's also hard because when we bundle, we're also making a shift from thinking about a PE being in one unit to a PE being in multiple units, because units aren't going to encapsulate the knowledge, they're actually going to contribute to knowledge. Number 3, communicate, 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 and then communicate some more. To be perfectly honest, I think in previous standards efforts, this has been a problem. We don't do that enough. There's actually got to be some work done. And you as a teacher we've done some studies, we've done some focus groups. Do you know who the public wants to hear from the most about education? I'll give you a hint. It starts with a T and ends with eachers.
Educators.
Educators works too. The public wants to hear from you, which means you've got to, I'm not saying you've got to be an expert on it, but knowing enough about it and also being the science teacher, which is, I think, different. Because a science teacher who is teaching kids to research stuff actually researches it themselves and doesn't go by just what they hear on the radio or what they read on the internet, but that they actually, understand. They actually have a way of communicating that to people. Number two, leadership makes the difference. Not a difference, the difference. Let me step out of the presentation for a minute. You know what? I love being a teacher. It's all I ever wanted to do. It excites me in a way that nothing else I've ever done has ever done. You say, well, why did you leave the classroom? Not because I didn't like doing that, but because I wanted to try to help more folks. And I've learned and I've realized that as a profession, we often forget we are one. Which means we lose the teacher voice. And we use the joke, I'm going to use my teacher voice to be loud and get people quiet. Our teacher voice is far more than that. Our teacher voice is what's right for kids. And that's the bigger part of what we're doing. And we've got to get past this idea that our teachers are the ones who are just the recipients of the decisions that are made higher and the ones that are actually pushing the decisions up. What's exciting to me about NGSS is it's being driven by the teachers. I hear teachers excited about NGSS. I hear teachers talking about what they're doing for their kids. So as a profession, we've got to get past that. We've got to use our teacher voice for more than just simply getting kids quiet and getting adults quiet. We've got to use our teacher voice to say this is what's right for kids. We're a profession, like doctors, lawyers. No doctor is going to say, oh, I don't think I want to learn how to do that today. Which leads me to my last point. 3D learning is hard. We don't help teachers or students by pretending it's not. I couple these together because, and I hadn't stepped back into my presentation completely yet. I will in a second. But here's the deal with this. We have got to get to a place that we realize that our profession is hard and quit telling people to make it teacher-proof and tell people to quit trying to tell us what teachers can't do. I personally am sick of it. As a teacher, I find it offensive. Every time I hear somebody say, NGSS is too complicated. Really? I don't remember a doctor ever saying, I'm not going to do that life-saving procedure because it's too complicated. For that matter, I don't remember ever hearing a doctor say, I'm not going to do that procedure because it was discovered in another state. So I'm going back in my presentation here. 3D learning is hard. If you go to sessions here and you go and you listen to people and your district brings people in to talk to you and they tell you they've got it all figured out, you should give the old Spock eyebrow and tell them that's just not logical. You can't have it all figured out yet. I mean, education is something that's on a continuum that never ends. And 3D learning, just because I can look at something that says a lab that has an investigation, and there's a word in there that says they're going to do a pattern, and it says something about ecosystems, does not mean it's three-dimensional learning. But we have to quit pretending that it's easy. We have to quit pretending that education is easy. And we have to get the people who are making decisions above us to stop trying to make it easy. That's why I find it offensive when somebody says, oh, this is too tough for teachers. Yeah, right? You go sit in that classroom with 30 kids. Give them all scalpels. Let them you go sit and watch them do dissecting. They all got knives. And you gave them to them. You go sit in a room with hydrochloric acid. Right? I mean, that's the thing. We've got to get to that place. So I've learned this because as we work with teachers to develop the model content frameworks, the evidence statements, the equip rubric, the thing we just keep finding is it's hard. So what? You know the old saying, if it was easy, everybody would do it? You don't have to actually raise your hands on this, but how many of you just get freaking tired of, the old saying, those who can do, those who can teach. Well, okay, you know what? I'm completely sick of that. Because I have known many, many educators in my life, and what I've learned, they're the toughest, they're the smartest, and they're the most innovative people in the world. Now, they can also be tough, to deal with. But you know what? At the end of the day, they care about kids. So what I'd like for you to do with this last one is, as you're working in your districts, if you're in a state that's adopted, if you're in a district that's adopted, if you're just know this is what's best for kids, and somebody's trying to tell you, hey, let's pull this down for you a little bit, just hit them. Actually, don't do that. I shouldn't promote violence. But I can't tell you the number of times I walk into sessions, not at NSTA, although it's happened a couple times here too, but across the country when I walk in and somebody has taken the appendix and turned it into a page. Because teachers need a quick reference. You're losing some stuff in there. That's where that depth is. It's a good reference guide. Okay, I mean, like the stuff that NSTA did. It's a reference guide, but the people that you go and talk to around instructional materials, if they're telling you, hey, to help you out, I put it on one page. Let me tell you something. We didn't do through Appendix O because I just needed something else to write. Okay? So the next time they say, I helped you out, I put it on one page, you just look at them and say, I'm going to help you out. I'm going to leave. Or I'm going to help you out. I'm going to explain to you what this means for my kids. That's actually what's going to be most powerful.